Hello everyone, welcome to Gradeup. I am Shantanu and today we are here for the live quiz session of industrial engineering. Okay, this session was scheduled earlier for 10th of this month, but due to some reasons we were not able to conduct it on 10th. But today we are going to conduct this session. Okay, so it is a very important subject, industrial engineering. Okay, it will come with around 4 to 5 marks weightage in the GATE 2019. Okay, and this is a very conceptual subject. You this is the completely a numerical kind of a subject. The theory problems rarely come from this topic. Okay, so we will be taking not many questions, only 5-6 questions, the quality questions we will be taking, and then we will see what are the concepts that are involved in this subject or the topics or the questions that we are going to discuss. Okay, so let us take the first problem. Okay, read the problem. Okay, tell me the topic from which it is, what will be the concept used and how to solve it. I will give you just 2 to 3 minutes. Okay, and then we will discuss the solution. So let us read this question. This says maximize z equal to 3x1 plus 2x2 subjected to 2x1 plus 3x2 less than equal to 9 minus x1 minus 5x2 greater than equal to minus 20. Calculate the value of x1 in the second feasible solution solving by simplex method. Good evening to all our viewers who have joined us right now. Sanket Zingade, this is only for mechanical branch. Okay, and some questions like the PERT CPM and the transportation assignment problem, these kind of questions come in the civil engineering, that too for the subject of means in the examination of engineering services. Okay, so this subject is, I can tell you, this subject is only for mechanical engineering. That is, you might have read it by the name of industrial engineering, either industrial engineering or the subject of operations research. Neeraj Singh is saying that this is from LLP, that is linear programming. Okay, linear programming, but there are two categories in linear programming also. One is the graphical method. Okay, one is the graphical method and the second one is the simplex. Okay, so since this is a 2 by 2 problem, it can even be solved by graphical method, but the question it is asked that you have to tell the value of x1 in the second feasible solution solving by simplex method. Okay, so you have to use the simplex method only. Okay, so I have told you the topic, that it is from the linear programming simplex. Now just take 2 minutes and try to solve this problem. Okay, you have to draw the table, the simplex table in this. Okay, and then see that how to solve this problem. Okay, do it. First of all, the equation that has been given as z equation. Okay, that is the, what is that equation known as? That equation is known as the equation which we need to maximize or minimize. In this case, it is a maximization problem. So we need to maximize z equal to 3x1 plus 2x2. And the other two equations which are given, they are known as the constraint equations. Okay, and that has been given as 2x1 plus 3x2 less than equal to 9. Okay, one more thing to be noted down here is, when this is a maximization problem, these constraint equations are in a less than equal to format. If they are not, then you please kindly change them to less than equal to format and then try to solve it. Okay, because see, in the second equation it is given in the greater than equal to format. So what you do, you just convert it into less than equal to format just by multiplying both sides by minus. Okay, minus 1, or simply by changing the sign. So that equation will become x1 plus 5x2 less than equal to 20. Okay. Okay, then what you do? Since these are not the equal to equations. These are inequalities. So what you have to do, you have to change them to the equal to equations by introducing the slack variables. They are known as the slack variables, plus S1 equal to 9 plus S2 equal to 20. Okay. Then the conditions of them, the constraints, that is x1, the variables x1, x2, s1 and s2 all are greater than and equal to 0. Okay. So these are the equations. This is the maximization. You have to maximize these two, means this equation, that is 3x1 plus 2x2, subject to these constraints, where the constraints, the in less than equal to constraints, we have changed it to equal to constraints by introducing two slack variables s1 and s2, and all the variables and all the slack variables are also greater than equal to 0, means they are positive. Okay, these are the equation formation. Now we have to construct a simplex table. Okay, how we will do that? See, I am just rubbing this one. Okay, just draw the table, the simplex table. Okay, if you know how to draw the simplex table, it is very good. You can draw it on your own, but if you have any problem in drawing that, just look here. Okay, Satyakant Mishra, some of the answers are coming 4.5, Shubhangi saying 6. Please, I will request all of you, just wait 2 more minutes. We are going through the solution. Let others also solve the problem so that they can also understand that what if they are not able to solve it on their own. Okay, so then they can look into this answer. Okay, so just draw a simplex table in this format. Okay, draw the simplex table in this format. Write down the variables, whatever are there, like x1, x2, s1, s2, okay, s1, s2, okay, and then the RHS value. What is that RHS value? I am going to tell you right now. Okay, so let me rub this thing also so that I can get some more space above this. Okay, now see, above these values, what you do, you write the coefficients value of the maximization equation, that was 3x1 plus 2x2. Okay, so 3x1 plus 2x2 plus 0s1 plus 0s2, because s1 and s2 we have introduced from our own side, so they're taking them as 0. Okay, so just writing them here, that is 3, 2, 0, 0. Okay, RHS value is not there. Okay, the RHS value is not there, so just writing it in this way. Okay, now what you do, considering S1 and S2 as the basic variables, S1 and S2 as the basic variables, you write them here. Okay, and their coefficients also this here. Okay, 0s1 and 0s2. Now, there were two constraint equations. Okay, so just writing the coefficients of those constraint equations here. The first one was 2x1 plus 3x2 plus s1 equal to 9. Okay, 2x1 plus 3x2 plus s1 coefficient is 1 and 9. Write that value equal to 9 in the RHS column. Okay, next, the next equation was x1 plus 5x2 plus s2 equal to 0. So x1, that is 1 plus 5x2 plus 0s1 plus s2 equal to 20. Okay, and here it is 0, because in the first equation s2 is not there, and in the second equation s1 is not there. Okay, now you have to find out one thing that is known as Cj minus Zj. Okay, what is that? What is that Cj minus Zj? How you will find that? See, these terms are the Cj terms. Okay, Cj are the coefficient of variables in the objective function, that maximize z equal to 3x1 plus 2x2, that is the objective function, and the coefficients of the variables in the objective functions are the Cj values. Okay, these are the Cj values. Now how you will find the Zj value? The Zj value you will find just by multiplying these terms. Okay, because this is, we are going through the first iteration, and in the first iteration all the coefficients of S1 and S2 are 0. So Zj in all for each term in this first iteration will be 0, because you will multiply 0 by 2, that will be 0, 0 plus 1 will be 0. So 3 minus 0 will be equal to 0, 3 minus 0 will be equal to 3. So in this case, then the first iteration, all those values will be copied here directly. Okay, I hope you get this. Why these values are copied here directly? Yes, Zj is 0. Ritesh Raj, you are absolutely right, but this is only for the first iteration. Okay, not for the for every iteration or for the other iteration. In this iteration, the first iteration, this value, the Zj value is 0, because the coefficients of the basic variables in this case are 0. Okay, now what you do? Yes, in the first iteration. Yes, absolutely right, Ritesh. Your concept is absolutely great. Now what you do, you find the, because this is a maximization problem, you have to find the value which is the highest among all these. Okay, that will, the variable corresponding to that value will enter the basis now. Because this is the maximum value, so this value will enter. That means the x1, which is a non-basic variable in the first iteration, that will enter the basis in the second iteration. Okay, and what will be the leaving variable? Because in the first iteration we have considered S1 and S2 as the basic variable, but now because x1 has to enter the basis, so either S1 or S2 will leave the basis. How we will find it out? What we will do, we will divide the RHS value, both the RHS values, by the corresponding terms or corresponding values of the entering column. What are the entering columns? Here, 9 by 2, this value becomes 4.5, and this is 1, so 20 divided by 1 gives you 20. Then what you have to do? Here you find out the maximum value, that is the entering value, and the leaving variable or the leaving variable, you have to find out the minimum value of these two. The minimum value of these two is S1. Sandeep Kumar, Ritesh Raj, S2 is outgoing. No, S2 is not outgoing, S1 is outgoing. Please correct it, because here you have to find out the minimum value. Okay, not the 20 leaving variable. No, you have to find out the minimum value out of these. Okay, please look into this. I think you are getting somewhere wrong. Sandeep Kumar Roy Chaudhary, key element. This will be the element, or this is the row, that is the leaving variable. This S1 will be leaving the basis, X1 will be entering the basis. Okay, so this row becomes the pivot row. This is known as a pivot row. Okay, the leaving row is known as the pivot row, and this variable, the cross section of the entering column or the entering variable and the leaving variable, this value, that is 2, that becomes equal to, that is known as the pivot element. Okay, this is known as the pivot element. Okay, 4.5 leaving, Yogeshvi, absolutely right. Now what you do, in the second iteration, you have got that S1 has left, X1 has entered, so X1 and S2 will remain like this. Now just again copying the coefficients, X1 coefficient is 3, S2 coefficient is again 0. Okay, now what you do? Now what you have to do, divide the every term of this leaving row or the pivot row by these values, that is by the pivot element. So 2 divided by 2 gives you 1, 3 divided by 2 gives you 3 by 2, 1 divided by 2 gives you 1 by 2, and 0 divided by gives you 0, and this value will become as 9 by 2. Okay. Yes, pivot element is 2. Charanji, absolutely right. Okay. Now what you do, see, what you have to make in this iterations, S1, S2, in the same order of their appearances, that is S1, S2, you have to make an identity matrix out here. See, 1, 0, 0, 1, S1, S2 in the same order. Now here it is X1, S2. Here it is X1, S2, that means X1 and S2. So you have to make an identity matrix of this column and of this column, that is 1 0 0 1. So you have to perform some kind of transformations like you perform while finding out the rank in the matrix. Okay, so you have to do such same thing here, and 1 0 0 1. So you have to get a 0 here. How you will get the 0 here? When you will subtract this value, 1 minus 1 will give you 0. So you have to do simply subtract these values or this row by this row. So 1 minus 1 will give you a 0. 5 minus 3 by 2 will give you 5 minus 3 by 2 will give you 7 by 2. Okay, this will give you a 7 by 2. 0 minus 1 by 2 will give you minus 1 by 2, and 1 minus 0 will give you 1. So here you can see now in the order of appearance, that is x1 and s2, you get an identity matrix 1 0 0 1. Okay, now finding out the Cj minus Zj, that is not basically required because it has asked you the value or the the value of x1 in the second feasible solution. This is a second feasible solution, and your answer becomes equal to 9 by 2. Okay, that is simple. You have to find out the value of x1, so that becomes equal to 9 by 2. Okay, but the iteration will stop only after you have arrived at any of the negative values here. Okay, either you arrive at the negative values or some of the values as 0. Okay, or if there is only one negative value, that means the iteration has stopped and you have got a unique solution to this linear programming problem. But if you get some values equals or 0 values, that means that there is multiple solution or the multiple optimal solution for this problem. Okay, I have taken too much time in this question. Okay, but I think, or I suppose that these concepts must be really clear in your mind, that how you got all this. Okay, so moving on to the next question. Read the next question. This is an assignment problem. Okay, read this. I'm just giving you 2 minutes time. Read this and solve it fast. This is an assignment problem. The first solution or the initial basic solution, basic feasible solution has been given, but we have to find out an optimal solution. This is not an optimal solution because this is a 5 by 5 matrix. Okay, 5 rows, 5 columns, but the assignments are only 4. Okay, so this is not feasible. You have to find out the optimal solution. Vijay Joshua is asking, minimization problem important? Minimization problem may be asked. You cannot neglect. Okay, just practice. The same for things happen in that also, in the simplex. The only thing is that while we were considering the maximum values of the Cj minus Zj that enters the basis, in that case in the minimization problem that becomes the negative value or the least value. Okay, so try to do this one. Prajwal is asking assignment problem for mechanical. Yes, Prajwal, assignment problems comes for mechanical. Surely the questions have appeared in the examination and they may come again also. Okay, so you have to do that. The initial basic feasible solution has been given, but that is not the optimal solution. Why? Because I have already told you, because there are only 4 assignments that have been done, but this is a 5 by 5 matrix. So you need exactly 5 assignments. Okay. Tushar is asking, PERT CPM important? Yes, PERT CPM is absolutely important. I have one question for PERT CPM. That too, we will consider a problem on crashing. Okay. Sometime the question of crashing has been asked, so we will be taking that one also. So please do this without wasting any time. Okay, just what you do, write down these terms first. Okay, without wasting much time. This is a 5 by 5 problem. Okay. So 5 by 5 problem, the values given are 10, 10, 14, 25, 0. Okay, then 0, 12, 25, 17, 15. Okay, then 10, 12, 19, 0, 10, 5, 6, 4, 7, 0, and 2, 0, 0, 5, 7. Okay, and the assignments have been made. One assignment is here. Okay, one assignment is here. Then one assignment is here. And the last one is this one. Okay, so this goes off. And as one is here, so this goes off. So now, forecasting is absolutely important. I have one question for forecasting also. Let us see if time permits, we will take that problem also. Okay, forecasting is a very easy topic. Okay, so now what you do, starting with this one, you have to make some transformations in this also. What you do, you have to make some ticks. You have to make some ticks. What you do, see, first of all, ticked a row which has an unassigned 0. This is the row which has 0, but this is an unassigned 0. Okay, so just tick it out here. Okay, then in the ticked row, find out if there is any 0. Okay, find out if there is any 0. This is the 0. Mark the column corresponding to the ticked row which has 0. Then in that row, in that column, find any other 0. Yes, there is one more 0 here. So this iteration will continue. First of all, you have to find a row which has an unassigned 0. Tick that or mark that. Then in that row, find out a 0. Mark that column. Then in that column, find a 0. Mark that row, and that iteration will continue. Okay, till no more ticking is possible. Then what you have to do, mark unticked rows and ticked columns. Okay, marked unticked rows and ticked columns. That is, this is an unticked row, this is an unticked row, this is an unticked row. Okay, unticked rows and ticked columns. This is our ticked column. Okay, now you can check one thing here, that the total number of lines that we have drawn, the possible number of lines covering all the zeros are 4. 1, 2, 3 and 4. And the solutions, the assignments which we have got was also 4. Okay, so you will get only those many number of lines that is equal to the number of assigned zeros. Okay, that is one more thing to note down here. Now what you do, you have to find a value theta. We call the value theta, that is the minimum value. This is the minimum value unassigned. That is the minimum value, you can ask uncovered. Okay, from the uncovered, that is uncovered. Yes, uncovered. So from the all these uncovered, the minimum value is this. So this becomes our theta. Okay, this becomes our theta. So what we have to do, subtract this theta from the uncovered values, add theta. Okay, subtract theta from uncovered values, add theta to those values which have 2 lines through them. Okay, and rest remains the same. Rest remains the same. Okay, rest remains the same. So moving on this line, what we do, moving with this, what we do, see. So theta is, I am saying that subtract the theta from the uncovered values. So making this again really fast. Okay, so 10 minus 4 becomes 6. Okay, 10 minus 4 will become 6. Again here, 10 minus 4, 6. 14 minus 4, 10. This will become 21. This will remain as such. Okay, So this will remain as such because only one line is passing. So 0, 12, 25, 17. Since here two lines are passing, so this theta will add here. So this will become 19. Okay, again here 10, 12, 19, 0, and here again theta will add, this will become 14. Here 5 minus 1, 6 minus 4, 2, 4 minus 4 becomes 0, 7 minus 4 becomes 3, and again here this will remain as such. Here also leave them like that only. 2, 0, 0, 5, and add theta to this, this will become 11. Now we have how many zeros? Okay, now let us start assigning. Okay, now let us start assigning first row. First row, we have an assignment here. Okay, at this point we have an assignment, so we make an assignment here. Okay, any other zero in this column will get struck off because they cannot be assigned. Okay, in this one, this get assigned. Okay, no other zeros. In this will get assigned. Okay, in this will get assigned. So this will get struck off and this will get assigned in this one. So finally we have arrived at an optimal solution. This is a 5 by 5 matrix and we have got the 5 solutions. Okay, the 5 solutions. Okay, so that's why this is an important concept. We have got the 5 zeros, but it was possible that we would not have got the 5 zeros at this point of time. Then we have to continue the same process again of ticking, finding out the theta values, subtracting the theta from the uncovered values, adding the theta to the values which have 2 lines across them and leaving rest other same, creating more zeros and doing this assignment until and unless we get the 5 assignment for this. Okay? Is this okay? Okay. If you want, you can take the screenshot of this last assignment. Okay. This was an easy problem. This kind of questions usually come in the examination. Okay. Sandeep Kumar, you have done. That's very good. Krishna Chaitanya is asking, I have left industrial and OR. Which topics can I see at the last minute for exam? Assignment is an important topic. Okay. PERT CPM is important, forecasting is important. So from these topics, the question usually come every year, so you cannot leave them. If you go through these topics this time at the last point of time, then also you can get good. See, cancellation of lines. What do you want? Vijay Joshua, cancellation of lines. Theta value is the minimum value which are uncovered. From these, the uncovered values are these 10, 10, 14, 25, 5, 6, 4 and 7. So the minimum of them is 4. Okay. So that's why this is the theta value. Okay. So read the next problem. Yes, this is the problem of PERT. Okay. This is the problem of PERT CPM with a crashing problem. Okay. Please read it fast. Okay. We can't give too much time to each and every problem. Okay, around half an hour is already passed. 27, 28 minutes have already passed and we are just into the third problem. Okay, but learning the concept is also good in these kind of problems. Okay, so just see the next problem. This is the PERT CPM problem. Sir, how the ticking is done? Ticking says starting you have ticked and cancelled. See, ticking in that problem, I have told you that ticking is done. Okay, Vijay Joshua, Mohit Surwade, if you are having some problem in the ticking, I have told you that if the time permits, I will take up at the end of this session. Okay, just let me take 3-4 more questions, then I will get to that problem. Okay, so just read this question fast. There are some activities given, the normal duration given, the crash duration given in weeks, and the cost of crashing has been given, that is per week. Prakhar Goyal, not clear. Can you specify what is not clear? Then I can answer. Question is not clear, sir. This one or the last one you are talking about? Sandeep Kumar, you have not done crashing, no problem, we will solve it here. No problem. Prakhar, which question you are asking? Question is not clear. Which one? Okay, now see, first of all we will draw the diagram, the network diagram for this. The activities have been given, okay, 1 to 2, 1 to 3, 1 to 4. Okay, so just draw that. 1, 2, 3, 4, 5. Okay, now let me draw it bit here. Okay, 1, 2, 3, 4, 5. This one, sir, data is not clear. Okay, I am writing the data, no problem. Just see it. 1 to 2, 1 to 4, 1 to 3, then 2 to 4, 3 to 4 and 4 to 5. The durations have been given as 9, 15, 7, 5, 9 and 4. These are the normal values. Okay, now first of all we will find out the critical path. Okay, finding out the using the forward computation and the backward computation. Okay, so starting from here, from 0, from here we get 9, from here we get 7. Okay, this we are doing the forward computation. Okay, just remember one thing, in the forward computation you have to find out the maximum duration, and in the backward computation you have to find out the minimum of them. Okay, what is that? I will tell you. See, going from 1 to 2 there is only one path, that is this one. So there is only one value. Going from 1 to 3 is also one path, this having the duration 7, so 1. But from 1 to 4 there are 3 paths. One is by this 1 2, 2 4, 1 4 direct, 1 3, 3 4. So the value here at 4 will come the maximum of those. 9 plus 5 is 14, this is 15, 7 plus 9 is 16. So here the value will come as 16. This is the meaning of the calculation of the forward pass computation, that is taking the maximum value. And here there is only one, so 16 plus 2 is 18. Okay, 16 plus 2 is 18. Now the normal is 18. Now we have to find out the backward pass computation, finding out from here 18. 18 minus 2 is 16. Now again, in the backward pass computation you have to find out the minimum value, this way only. Okay, so from going from 4 to 3, 4 to 2, there is only one path. So 16 minus 5 will give you 11. Okay, 16 minus 9 will give you 7. And for reaching 1 there are 3 paths again. From 4 to 2, 2 to 1, direct from 4 to 1, and 4 to 3, 3 to 1. Okay, so the minimum value 11 minus 9 will give you 2. 16 minus 15 will give you 1. 7 minus 7 will give you a 0. So here it will come 0. Okay, so the critical path for this case becomes 1 to 2, 1 to 3, 3 to 4 and 4 to 5. So this is your critical path in this case. 1 to 2, 2 to 3, 1 to 2, 1 to 3, 3 to 4 and 4 to 5. That is 1, 3, 4, 5. And the activity duration is 18 days. The cost has been given to you as 50. So the normal cost of this project will be 18 into 50, that is 900. Okay, 18 minus 18. If you have completed this chapter, that is very good. Ravi Ranjan Kumar, very good. Okay, so this is 900 is the normal cost, but we are not talking about the normal cost. We are talking about the crashing cost. If this project has to be crashed by 2 weeks. Now what you do? See, in this path or in this project, find out among the critical paths. These are the critical paths: 1 to 3, 3 to 5 and 4 to 5. 1, 3, 3, 4 and 4, 5. Okay, so then among these paths, you have to find out those value which has the minimum crashing cost per week. So 1 to 3, 1, 3, 3, 4, 4, 5. The crashing cost has been given as, for 1, 3, the crashing cost has been given as 20. For 3, 4, the crashing cost has been given as 15. And for 4, 5, the crashing cost has been given as 30. So this is the minimum. So we will crash this we will crash this path, that is this activity 3, 4 by 1 week. By 1 week. Okay. Can we crash an activity up to 0 by again and again up to minimum, no critical path, or up to just crash duration? Please clear. See Shubhangi, the critical path cannot be changed in that way. When you are crashing the project or any activity, the critical path must not change. Okay, the critical path, this means the original critical path must not change. There may be some more critical paths that are created in that process, but the original critical path must not change. Okay, that is the basic condition. And any cost or any article or any any activity can be crushed only up to that much duration. What is the crash duration has been given. Okay, so I am saying in that first we will crash the 3, 4 by 1 week. See 3, 4. 3, 4 the normal duration is 9. It can be crashed up to 6. Okay, so means it can be crashed 3 weeks. So we will just crash it 1 week. So we will get, okay, then again we have to find out the critical path first of all. So just rubbing these. Okay, so now we will crash this by 1 week. So this becomes 8. Okay. This is 8. Now see, again doing that forward pass and backward pass computation, this becomes 0. This is 9. This is 7. Okay, 7 plus 8, 15. 15. 9 plus 5, 14. So this will become 15 and 15 plus 2 is 17. So doing the backward pass, 15, 17, 15. 15 minus 8, 7. 15 minus 5, 10. And 15 minus 15, 0. 10 minus 9, 1. 7 minus 7, 0. Okay, so now there are two critical paths that we have created. One is this original critical path is there. Okay, but one more critical path has been created now. That is 1, 4 and 4, 5. That is also critical path. Okay, that is also critical path. Okay, now what you do? Now, because the project has been crashed only once by 1 week, but in the question it is saying that you have to crash the project by 2 weeks, or the project duration has to be reduced by 2 weeks. So for that, what you will do? Now you will find out such activities along. Why can't we crash 3, 4 by 2 days here, sir? 3, 4 by 2 days. We will do it one by one. That is basically the you will understand why we can't crash it by 2 weeks. Just now you can see here. See. Okay, now you see here. Now the critical paths. Now there are two options. Now there are two options to crash. Either we crash 1, 4 and because now we have the two critical paths. So we have to crash two activities once at one time. So either we crash 3, 4, 1, 4 and 3, 4 or 1, 4 and 1, 4 and 1, 3. And one more is possible. That is, we can crash 4, 5 also if it is possible. See, now just find out the cost. That is 1, 4 crash cost is 1, 4 crash cost is 25 plus 15. That gives you 40. Okay, that gives you 40. For 1, 4 and 1, 3, the cost is 25 plus 20. That is equal to 45, and for 4, 5, the crashing cost per week has been given to you as 30. Okay, so now in this iteration, it is feasible to crash this one. You cannot crash again either 1, 4, 1, 3 or 1, 4, 3, 4. Okay, so now you have to crash 4, 5. Just crash 4, 5 by 1 week because it is possible. The 4, 5 is, the normal duration is 2 and it can be crashed by 1 week. So just again, now you have got crashing 4, 5 by 1 week. Okay. So just crash this by 1 week. This is already 8. Crashing this by 1 week will give you 1. Again finding out the in the last case you can see the cost duration, and that has become 17 into 50 plus increasing the crash cost. Okay, that will be 865. The normal one was 900. This is 865. Okay, now in this case again doing the forward pass computation 9. 0, 9, 9, 5, 14. Okay, let us see here first. 7. Okay, this is 9, 5, 14, 15, 15. So this will be 15. Okay, and this will be 16. Now doing the backward pass computation, 16, 15, 15 minus 5 is 10, 15 minus 8 is 7. Now here going here, this will become 0. Okay, now there are the critical paths, that is 0, 0, 15, 15. This is one critical path and this is another critical path. So we haven't changed the originally critical path that we have got. So what will be the answer but 16 into 50. Okay, 16 days 50 plus 16 day 50 plus 15 is the original that we have got here by crashing this, plus 30, that is of what? That is of this one, 4, 5 that we crashed. So this you will get the answer as 800, 815, 845. Okay, so this is the answer for this one, that the answer is 845. Okay, I hope this is clear to everyone. First crashing 3, 4 and then 4, 5. See Abhishek Bauguna, the velocity and acceleration analysis, that is you are talking about the subject of theory of machine, that we have covered in a detail. We have taken some super quizzes, the live quizzes of that. If you have any problem, you can go through those videos in the Gradeup classroom as well, and also in the live sessions that we have conducted in the past of that subject. And even if it is not possible, then you can post your comment in any of the why we are crashing 1, 4 and 3, 4. Because 1, 4 and 3, 4, because there are only two combinations which will not change the part, which will not change the critical path that we have created, that is 1, 4, 3, 4 and 1, 4, 1, 3. These are the combinations. Okay. Okay, I hope this question is clear. We are running short of time, so let us see the fourth question very quickly. The question is from the queuing theory. Very simple problem, just take half a minute to read it and another half a minute to solve this one. Very simple problem, nothing much to be explained, direct formula based question. See this. No, Praful, we cannot crash only 3, 4 because that will change the original critical path that we have got. Okay, see this one now. A train reservation facility has one counter capable of handling 100 requests per hour. Okay, so that is the service rate mu, given as mu equal to 100 per hour. The arrival rate, okay, the persons coming for reservation arrive at a mean rate of 90 per hour. So that means that is the arrival rate given by 90 per hour. So from here we find out one thing that is known as rho. Rho is alpha by mu, which is equal to 90 by 100, that is equal to 0.9. Then what is asked? It is asked what is the average length of the queue at each counter, because there is only one counter. Okay, so that average length of queue, the formula is rho square upon 1 minus rho. Okay, for this chapter, do not go into that probability type of questions because they are never asked. Okay, this is a simple tip. Just learn, just understand, or just solve the problems, practice the problems which are direct formula based. Okay, so rho square upon 1 minus rho is 0.9, so 0.9 is square upon 1 minus 0.9, so that is basically 0.81 divided by 0.1, so this will give you the answer as 8.1. Yes, everyone is giving the right answer, not 9. Sandeep Kumar, please, 8.1 is the answer. Okay, very simple problem. Read the next one. This is an inventory control problem with a shortage. Please read it carefully and just give me the answer for this one. This is also a formula based question. Okay, the first 3 questions what we discussed today, they were conceptual problems. The last 3 are the problems, they are directly formula based. Just read it fast. The demand of an item is 20 units per period. Okay, so keep writing fast. Demand is 20 units per period. Okay, then it is given the shortage cost of 0.8 rupees per unit per period. This is shortage cost, CB, 0.8 per unit per period. Okay. Next, the inventory carrying cost is 20% of item cost per period. The item cost is 8. Okay, that is the item cost is 8. The cost of making purchase is rupees 18. That is the purchasing cost or the holding cost. Okay. That is the purchasing or the ordering cost. That is rupees 18. Okay, 18. The holding cost or the carrying cost is 18% or is 20%. 20% of the item cost given as 8. So that will be 20% of 8, which is nothing, which will be equal to 1.6. Okay. Mean indirect cost. There are two kinds of cost, that is the direct cost and the indirect cost. While crashing, the direct cost decreases, the indirect cost increases. Okay. The direct costs are the cost like the cost of a building, the cost of the infrastructure, which decreases. But the indirect cost like the cost of labor, the machine, those increases during the crashing. Okay, we arrive at a optimal solution where at a arrival means this is a kind of curve that we get in that case. This is for the direct cost, this is for the indirect cost. Okay, we arrive at this value, this is the optimal solution or the optimum cost for the crashing. Okay. So, in this what is asked? The economic order quantity, the EOQ. In this case, the EOQ is given by 2D C0 by CH root over into, because this is a crash shortage, CB plus CH upon CB. Okay. All the values have been given to you. CH, CB, D, C0, CH. Just put those values here, get the answer. You should get the answer as 36.74 units. Okay. Nothing much to be explained in this. This is again a very easy problem. Okay. Not 12.24. Viraj, you are doing something wrong. Satyakant Mishra, you are absolutely right. 36.74. Yes. Now read the last question. We are into the last question. That is the question of forecasting. Okay. Read it. The sale of a car in a showroom in first, second and third months are, okay, that is D1, D2, D3. These are the actual sales. That means these are the demands. 70, 68 and 82. These are the demands. The smoothing constant denoted by alpha given as 0.4. We have to find out the forecast for the next month. That is the fourth month. Okay, in this case, the forecast for the first month has not been given. So the forecast for the first month will be equal to the demand of the first month. In such cases where the forecast for the first month is not given, consider the actual demand that is given for the first month as the forecast for that month. That will be equal to 70. Okay, and then use the formula, that is Ft equal to Ft minus 1 plus alpha dt minus 1 minus Ft minus 1. Okay, so F2 equal to F1 plus alpha D1 minus F1. F1 is 70. We have done here 70 plus 0.4, 70 minus 70. That you will get as 70 minus 70 is 0. So 0 into 0.4, 0. This will become F2. This is F2. Finding out the F3. F3 will be F2 plus alpha D2 minus F2. Okay, so F2 is 70 plus alpha 0.4, D2 is 68, 68 minus 70. This value you will get as 69.2. Okay, now you have to find out the F4. Okay, find out the F4. F4 is equal to F3 plus alpha D3 minus F3. Okay, F3 we have got as 69.2 plus alpha 0.4, D3 is 82, 82 minus 69.2, and this is equal to how much? This will become equal to 74.32. This is only asked F4. So this is your answer. The only important concept in this question was that if the forecast for the first month is not given, consider that equal to D1 and proceed. Okay. So these are all the questions that we have to discuss in this session. Okay, I hope you enjoy this session. The maths class, the engineering maths class, we conducted 6 engineering maths class also. That was completed yesterday evening. Okay, so there is one good announcement for you all, that we are coming up with the general aptitude classes very soon for all of you. Okay, they are most probably coming from Monday. Okay, so I hope you will learn something out of those things. Okay, so thank you for watching this session. Keep learning. If you have any problems, any doubts, you can write to us on the comment section, ask your queries. And if you have any problem in revision, we have provided you the lecture series on the Gradeup classroom. We have conducted so many live sessions as well on YouTube. Okay, so you can do that. So the classes of the maths classes have been done now. Only the important topics have been done, considering the English and the GA classes are coming for you right from Monday. Okay, you will be notified about the timings and all. Okay, so thank you for being with us in this session. Thank you. All those maths classes are available in YouTube. Yes, the 6 classes of the maths are already available. You can watch them. They are taken by Dinesh sir. Okay, so the video or heat transfer have been done in the Gradeup classroom. The quiz sessions have also been conducted. Okay, you can watch them. Okay, so that's all. We will wind up this session. Thank you.